Hey guys, I'm going to be doing number 14 in the chapter 18 homework. And the question asks, calculate the power delivered to each resistor in the circuit shown figure. Um, from the diagram, we can see that there's four resistors, one on the top, one on the bottom, both of them being series, and then two on the side being parallel. Right off the bat, I wanted to find the resistance total on the parallel. So I used the reciprocal equation, and I was able to get the resistance of 0.75 ohms for the parallel. And then I just drew a little diagram to show you what it looks like if it were all a series. Um, and that just makes it easier to uh, visualize. And from there, I was able to find the resistance of the whole system. And if you add up all the resistances, you will find that the total resistance is 6.75 ohms. From there, since we're given the volts and we just found uh, the resistance as a whole, we're able to find the current, which is 2.6 repeating amps. And with that current and with the resistance found, um, we're able to solve for our very first power, which is the top one. And if you plug in IR for V, you get the formula P equals I squared R. And with that, I squared the current found, and then I multiplied it by the first resistance, which is 2 ohms, and then you get the first power, which is 14.2 watts, and it's the top one. And then on the bottom, it's sort of the same thing. Use the same current, and then since the resistance for the bottom one is 4 ohms, you just multiply it by 4 instead of 2. And then for the power, since we're not given the voltage for that part, since the voltage ends up changing in the parallel, you have to solve for the voltage. And since we're given the current, which is constant, and we found the resistance of the parallel system, we're able to find the voltage, which is 2 volts. And then with that voltage and deriving the power formula a little bit with I equals V over R, we're able to find the formula P equals V squared over R. And if you plug in the voltage for the parallel, which is 2, and you square it and you divide it by the resistance, which if you take the left one first, which is 3 ohms, you get the power to be 1.3 repeating watts. And then for the very last one on the very right side, you do the exact same thing as the one previously, and you use the same volts too, and you square it and you divide it by the resistance, which is given as 1 ohm. So it'll be 4 divided by 1, which is 4 watts. So the powers, the top one is 14.2 watts. The bottom one is 28.5 watts. R2, or the one on the left side, the left in the parallel is 1.3 repeating watts. And then the one on the very side, the very right side, is 4 watts.